Hello students, welcome back. The final topic here is absolute value, or more precisely speaking, absolute value equations and inequalities. Absolute value, the definition is rather trivial. Here we go. If x is already positive, then keep as is. X is negative, put extra negative sign if necessary to make it positive. Okay, that's about it. Oh, by the way, the extra negative sign. For numbers, it wasn't really that necessary, but here for equation, that extra negative sign, that's going to be important. For example, if you actually have a number, absolute value of negative 17, for example, then nobody actually does it this kind of computation. Nobody does it this way. Everybody will simply take this number part and go from here to there directly. But when we have x expression, this putting extra negative, actually that plays some role. Here we go, absolute value equation. You see, just like x with negative x, we're having some x expression and negative of that x expression. So p of x is one x expression that equals to another x expression. So we have basically two equations combined together. Want to see an example? Okay, here we go. First example, 3x plus 2 in absolute value is equal to 7 minus 2x. How do you handle that? Let's see, let's go above. Plus or minus. So it's this. 3x plus 2 is equal to 7 minus 2x. That's 1. That's the top one, okay? I don't know, I'm having difficulty highlighting appropriately. What I meant was top. Oh, never mind. I can maybe do this separately. Okay, that'll work. Okay, alright. And then bottom one is 3x plus 2 equals to negative of 7 minus 2x. So basically this problem combines these two. So let's solve the blue equation. Flip this negative 2x to the other side. 3x plus 2x equals to 7 minus 2. So 5x is equal to 5. X is equal to 1. One solution. Good. How about the next? 3x plus 2 equals to negative 7 plus 2x. Distributing the negative. 3x minus 2x. If I flip it over, negative 7 minus 2, x equals to negative 9. We have those two solutions there. Let's see, are they okay? Let's check. Sorry, I just kept wrong key. Typos after typo. So what I want, x is equal to 1. So is this true? Let's find out. And 3 plus 2 is equal to 7 minus 2. 3 plus 2 is 5. Absolute value is 5. That looks okay to me. So this is great. How about the next? Okay, that's what we had before. And then x equals to -9, and that was -9. And will that turn out to be okay? Absolute value of -27 plus 2 is equal to 7 plus 18, negative, positive. -27, -25 is equal to 7 plus, 25. And absolute value of -25 is 25. That's okay. Yep. Everything checks out. By the way, this checking process is not a casual thing. It's an essential step. Whenever you have an equation that is not polynomial, then you'll have to do this. Actually, you know what? It's important to check every single time. Just invest about 1 minute, maybe, of your time to make sure you are doing your problem correctly. Am I making sense? Okay, I will make sense. I promise I will make a lot more sense through the next problem. Okay, all right, let's do this. So basically we want this equation or this equation. No more absolute value. Instead, we have negative sign. Okay, let's do this one first. 2x, flip this -3x to the other side. That's 3x equals to 4 minus 1, flipping numbers to the other side. So 5x equals to 3, x equals to 3/5. Looks good. Next. Alright, so 2x plus 1 is equal to -4 plus 3x after breaking up the parentheses. 2x minus 3x, if I flip x to the left hand side, -4 minus 1, minus x is equal to -5, x is equal to 5, another solution. Well, let's check. Oops. Okay, this one was what? 3/5? And then that one was 3/5. Alright, let's do the computation. And then this is 2 times 3, that's 6/5 plus 1 is equal to 4 minus, let's see, 9/5. And then that's, let's see, that's 5/5. So 11/5 is equal to, that's 20. Now let me write like this for the students who are already slow in mental math. Let me write like this. 20 over 5 minus 9 over 5. So 1 is 5/5. So left hand side, what do we get? 6 plus 5, so 11/5. Right hand side, what do you get? 20 minus 9, again 11/5. That looks okay to me. Alright, that was good. That checked out. How about the next one here? It's about write the equation. plug in x equals to 5. Okay, let's plug in x equals to 5 here. That's 10 plus 1, isn't it? Equal to 4 minus 15. 11 equals to negative 11. Does it look okay to you? Certainly not. This can happen. You see? Absolute value. Okay, anyway. If you have just linear equation or quadratic equation, in that case, you just solve it and those are solutions. You can just walk away. But otherwise, always it's a good idea to check back your answer. You have to do that. There's some theory behind it, but I thought about talking about it, but thought better of it. But as a matter of fact, in practice, it's always, no matter what kind of equation, always it's good to come back and check your answer. Even for something simple as, these kind of simple equation and that kind of simple equation, if you put those together, there was some non-trivial aspect here. Look at this. That's what absolute value does.